Now question number 15. Well, for the mathematics 2026. Now that number 15, a ball, that is 15A. A ball is thrown from the ground upward with a velocity of 30 meters per second. A second later, another ball held at rest is released from a height of 50 meters to hit the first ball. Figure 1, time when the balls meet. Figure 2, height at which the balls meet. We have to take G to be 10 meters per second square. Let's solve the first part. So we are coming to the second part. Now we have the first part of the question. So we have a ball. So we are going to use a simple sketch to illustrate the information from the question. A simple sketch. Then we have the sketch here. This is the sketch so that represent the information that we have in the question. So that is, if ball is thrown from the ground upward with a velocity of this. Now the one that is coming from the ground is with initial velocity u is said to be 30 meters per second square. That is the initial velocity. Now the time taken here, let's take this one to be t1. So the time taken here, let's represent it by using letter t. So that is, because we are told that a second later, the time taken. So the time taken for the ball coming from the ground to be t1, that is equal to t. Now a second later, another ball held at rest. Now this ball is held at rest. That means initial velocity is said to be 0. So because it's at rest. Now we are given the height. So the information we have here, the height is said to be 50 meters. The ball coming from the ground and the one held at rest that is coming from a height of 50 meters from the ground. So the initial velocity there is said to be 0. Now we have a constant value which is g. As acceleration due to gravity, g is said to be 10 meters per second square. So where here is also 10 meters, g is said to be 10 meters per second square. Now for upward motion, we have this one is upward motion, g is said to be negative, and for downward motion here, g is said to be positive. So that is the condition that we need to take note there. So now we are also given, let's take for instance the one that is coming from the ground there. So let's use letter x to represent the height at which the one coming from the ground meets the one that is released from a height of 50 meters. Now from here, so from this height to this height, now if from here to here is x and from here to here will be determined by taking away x from 50. So here we have 50 minus x. So therefore the distance the ball coming from that is held at rest, so we travel will now be 50 minus x, and the one coming from the ground here, so let's take this one to be x1. So this one x2 is x, that is the distance to travel by this one will now be x. Now the next thing is that, so we have this, then the time taken for this one will be x2, this will be x1. So let's take this one to be x1 to avoid contradiction. T1, S1, then this will be T2 now. So T2, since it's after a second before the ball was released at rest. So this ball held at rest before it was released, after a second that the first ball has been thrown from the ground. So therefore this will now be T minus 1. So using equation of motion, we are using this equation of motion so the equation that contains all these parameters is s equals to ut plus 1 over 2 at squared. This is equation of motion. We are going to convert to motion under gravity now using g. So therefore this one will now be s equals to, for s2 now we have ut, this one is in downward motion, then plus 1 over 2 gt squared. Let's substitute. Here we have s2 here, then we have s2 t2 here. S2 is 50 minus x equals to u. This will be u2 now. That is, we have 0 by t2. Then t2 here is t minus 1. So plus 1 over 2, g is 10. Then we have t2. We have t minus 1. Everything is to power 2. So we have 50 minus s equals 0 by t minus 1 will give us 0. Then 2 goes here, we have 5. That will be 5 into t minus 1 raised to power 2. So this implies by making x subject of the formula, take s to this side, then take this one to this side. The minus will change to positive. Then we have 50 minus 5 into t minus 1 raised to power 2. Call this one equation 1. Now coming to this one, we are using the same equation. That is, we have s equals to, that is s1 will now be equals to u1, then t1, then minus, since this one is upward motion 2, then we have d t1 raised to power 2. So therefore we have x equals to u 30 times t1, that will be t minus 1 over 2 times 10, then times t, that is t1 raised to power 2. So here we have s equals to 30t, 2 goes in 10, we have 5. So here we have minus 5t raised to power 2. Call this one equation 2. Now in equation 1 and 2, so since in 1 and 2, in equation 1 and equation 2, so x equals to s. So therefore we have 50 minus 5 into t minus 1 raised to power 2 equals to 30t minus 5t squared. 5 can go in all. 5 goes here, we have 10. 5 here we have 1, we have t minus 1 squared. 5 here we have 6, then 5 here we have t squared. So let's simplify further so that we can solve for t. Now we have 10, then minus t. So we have t minus 1, then times t minus 1. That is t minus 1 squared equals to 6t minus t squared. That will be 10 minus, let's open bracket here, we have t squared minus, that is t by minus 1 minus t, minus 1 by t minus t, minus t minus t, that will be minus 2t. Minus 1 by 1 will be plus 1. Then equals to 6t minus t squared. Open bracket, we have 10 minus t squared plus 2t, then minus 1 equals to 6t, then minus 6 minus t squared. We have t. Now t squared will cancel out. Minus return to plus. So when it crosses the bridge, so that the minus and plus will cancel out. So we have 10 plus 2t minus 1 equals to 6t. So now let's collect like terms. So when we take away 1 from 10, we have 9. So take 2t to the other side of the equation. We have 6t minus 2t. So we have 9 equals to 40. So divide both sides by 4 by 4. So this cancel out, we have t equals to 9 over 4. So the time when the balls meet, so that is Roman figure 1. So Roman figure 1, t is equals to 9 over 4, which is true whole number 1 over 4 seconds, or we have 2.25 seconds. This is the time at which the balls meet. Now Roman figure 2, I want to calculate the height at which the balls meet. Now to calculate the height at which the balls meet, we can use either equation 1 or equation 2. Now using the equation 2, we have x equals to 30t minus 5t squared. So we have s equals to 30t. T is 9 over 4. So we have 9 over 4, then minus 5 into 9 over 4 raised to power 2. So s equals to 2 goes here, we have 15 by 9 over 2. 2 goes here, we have 2. So 2 here, 15. Then we have minus 5 into 9 square, 81. 4 square, that will be 16. Now we have this. So when you multiply 15 by 9 divided by 2, you have 7.5. 5 by 2, 1 divided by 16, we have 25.3125. Taking away this from this, we have 42.18, then 75 meters. So that is from the ground. Now the height at which, so that is the height at which the balls meet from the ground now, equals to, we can approximate this to 2 decimal places as 42.19 meters, or to 1 decimal place as 42.2 meters. So from the ground now, from the ground, so that is from the ground, the balls meet at 42.2 meters. That is to 1 decimal place. So thank you. Please like, comment and share. If you have any question, you can drop in the comment section. Thank you.